Assalamualaikum warahmatullahi ta'ala wabarakatuh. How are you? Some okay? All right. So today we're going to finish up chapter 12. I will look at another example of the integration, and then we look at application 12.2, 12.4. And then, we go on to chapter number 13. Chapter number 13 on the definite integral. So that is our plan for today. So let's start with 12.2. The 12.2, I would like you to look at one example. We are still using the power rule, but here we need to have, you need to apply a slight, what do you call it? You need to apply a slight modification in order for us to be able to do the integration. So you look at the example 4. Okay, please look at example number 4. What you see there, okay, what you see there, you don't see or you don't have u prime. What you have is short of u prime by a constant. Okay, so in that case, what do you have to do? So that is the example that I would like to look at. Okay, here it is. If you look at example number 4, right? You look at example number 4. U is equal to the 5x to the power of 4 plus 11. Now, what is u prime? U prime is 20x cubed. All right. Now, according to the power rule, in order for us to be able to do the integration, you must have u to the power of n u prime dx. Then the integral will be u n plus 1 over n plus 1 plus a constant c. Okay, but what we have is we have what? You have you don't have 20x cubed. You have x cubed, not 20x cubed. All right. So in other words, more generally, what you have is the integral of u to the power of n. And then let's say instead of having u prime, you have, say, m. Okay, m dx. So now our objective is you need to make the m to be equal to u prime. Okay, so example here is this. The u prime should be 20x cubed. Okay, what you are given only u to the power of 3, which is not 20x cubed. So therefore, you don't have u prime. What you have is m. Okay, now you want to make it into u prime. How do you do that? So what you do here is this. What is the term that we are short of? What is the term that is missing? What term is missing? The term missing is the 20. Okay, the 20 is missing. You don't have 20. You are given only x cubed. All right. So what you do here, we multiply by a ratio of constant over a constant, say a over a, where a is a constant. So you do that, then you can make m into u prime. Now a over a is equal to 1. So when you multiply by a over a is equal to 1, that means you don't change the function. Okay, there is no change in the function. There's no change in f of x because you multiply by 1 over 1. So you must maintain that. You cannot change. So you cannot multiply by, say, a over b. Okay, you cannot do that. You can multiply by ratio of the same constant. So example, okay, in this case here, we are short by 20 over 20, so you multiply by 20 over 20. Or you multiply by, if you need U prime, you have to multiply by, say, 5 over 5. You cannot multiply by 5 over 10. Okay, this one you cannot. Why? Because this one you have 1 over 2, okay, which is not equal to 1. Everything here is equal to 1. Is that clear? You have to multiply by what? By a ratio of two constants that is equal to 1. It means ratio of the same constant. Okay? So for this example, U prime is 20x cubed, but you have only x cubed. So to make it 20x cubed, what do? We multiply by 20 over 20. So you multiply by 20 over 20 because that is what you need. Okay, you need 20x cubed. So our integral will become 5x to the power of 4 plus 11, everything to the power of 9. Now you multiply the 20 over 20 here. Okay, 20 over 20. And then you have the x, dx. So you multiply by 20 over 20. Why? Because U prime is equal to 20. And what you are given or what you have is x cubed. So in order to have that 20, you have to multiply by 20 over 20. Don't multiply by 20. Okay, you multiply by 20, you cannot do that. Okay, this is wrong. Because 20 is not equal to 1. Because if you multiply by 20, that will change the function. You have to multiply by 20 over 20. And that is equal to 1. Okay, all right. So now you have 20x cubed. So what you do, you reshuffle the terms a little bit. So that is equal to what? That is equal to, you bring the 120, the denominator outside. Then you have 5x to the power of 4 plus 11, everything to the power of 9. Now you have 20x cubed dx. Okay, so now you have the form. You have the form, the general power rule, which is what? Which is U to the power of n, U prime dx. So now you have that form. Okay, because U is 5x to the power of 4 plus 11 to the power of 9. And then U prime is 20x cubed. So by doing that, now I have here U, and that is U prime. But of course, don't forget, you have a constant there, 1 over 20. Okay, all right. So now what you have is, in terms of U, I can write it down now, 1 over 20. The integral of U to the power of 9, U prime dx. So that is equal to what? That's equal to 1 over 20. The constant will just follow the integral. U to the power of 10 divided by 10 plus C. And now you put back the U. What is U? U is the term, the one that you already multiplied by 5x to the power of 4 plus 11, everything to the power of 10 divided by 10. Okay. No. Kita dah multiply lah dengan 10 tu, so you don't need that division anymore. So what you have is 5x to the power of 4 plus 11 to the power of 10 plus C. Okay? Is that clear? Anybody has a question? We can multiply by ratio of the same constant so that you will have U prime. Okay, all right. I'll give you another example. So this one, I would like you to try, okay? The first person who get it, let me know. So let's say you have 7x to the power of 4 to the power of 3 minus 100. Okay, everything to the power of -4. You multiply by 5x squared. Okay, now I want you to do this. You let u prime be the terms in the bracket, and I'm sorry, you let u be the terms in the bracket, and then you tell me what is u prime. Okay, do it now. You tell me what be the u prime. Okay, what is the u prime? The u prime, is it 5x squared or is it not? Right? Okay, what is u prime? Anybody?
21x squared.
21x squared. Okay, but what we have 5x squared. So you will have to have the 21. So how do you what do you have to multiply that with in order that we get 21x squared from your given, okay, 5x. Okay, now multiplying apa? This one you don't have, you can, just give me a number. What do you multiply that with? Just give me a ratio of same number. So if you have u equal to 7x cubed minus 100, u prime should be 21x squared. Okay, but we have 5x squared. So now u1, u prime, okay, 5x squared is, I can add here, it's not u prime, it's m, okay? It's not u prime. So how can you make it u prime, which is 21 over x squared? What do you multiply that with? Okay, anybody has anybody who can suggest you multiply by what number? Ratio of what number? Somebody. Multiply what? Somebody suggest to me. What number? Oh, don't worry whether you got it wrong, right? Because this is just to try. Okay, multiply by nombor berapa? Berapa nombor?
Four.
If you multiply by 4, you cannot multiply by 4. You have to multiply by 4 over 4. If you multiply by 4 over 4, of course, that is equal to 1. But do you have 21? I just write the u prime, okay? I don't write the whole thing because you want to establish 21. You multiply by that, you will get 20, okay? 20. And of course, you have the, don't worry about the 4, but we want that. We need 21. Okay, so you cannot multiply by 4. A good try, but that is cannot. We cannot multiply by 4 over 4 because we will get 20. You want 21. Okay, anybody else?
4.2, sir.
4.2. Okay, if you multiply by 4.2 kali berapa? 4.2. You multiply by 4.2 times 5. You got 21. Okay. So that's a good idea. You multiply by 4.2. So one option, you multiply by 4.2 divided by 4.2. You can do that, but of course you have a decimal point. Okay, but if you do that, you dapat 21. You got 21 over 4, and then that 4, don't worry about it. You bring it out. Now, another thing is, or another way, or what can you multiply? If you multiply by just whole number, no decimal point, what number do you multiply that with? Ratio of what number? Okay, what you want is 21, right? So you multiply by what? 21 over 21. Okay, you multiply by 21 over 21. You don't worry what number is given, okay? What number that you have. You just multiply by 21 over 21, and then you got the 5x squared. Just rearrange, okay? Because what you need is that 21. You multiply by 21 over 21. So that is, this one you can do that. You can also do, you multiply by decimal point. But sometimes, what you get will not be exactly equal. Okay, you may have end up like decimal point 110. All right. So here you multiply by whole number. What you want is that number, so you multiply by the ratio of that number. Don't worry about what that number is given, because after that you will have to reshuffle. Okay. So I will write down here. You multiply by 21 over 21. So what you have is 7x cubed minus 100 power of -4, and then you multiply by 21 over 21, 5x squared dx. Erase. You rearrange, you maintain the 21x squared, and then 5 over 21 you bring out. So rearranging, you get 5 over 21, take it out, the constant, 7x cubed minus 100 to the power of 4. Now you have what? I have 21x squared dx. So you have the form u to the power of -4 u prime dx, right? Because u prime is 21x squared. Okay, all right. Any question? So you finish up. Okay, so the answer you will have 5 over 21 u to the power of -3 divided by -3, and then you put in u. All right. Okay. So the thing is, you multiply by ratio of a constant over constant, and the number, okay, the number that constant is the constant for that u. Don't worry about what we are given, just multiply back by the number what should be. Okay, so you multiply by 21 over 21. Okay, all right. For example, let's say I give you another one. Okay, this is just for making us better understand. Let's say here u prime is equal to 40x to the power of 4. All right, but what we have, which is in the question, I don't write the u because I don't know about the u. I just want to show how you multiply by the ratio of the same constant. But what we have is, say, what you have is 7x to the power of 4. All right, what you have is 7x to the power of 4. I want 40. All right, so what do we do? What ratio do you multiply that with? The ratio, constant. Multiply by what? You don't worry about that number 7. Okay, you want 40, so you multiply by what?
40.
Multiply by 40 over 40. Don't multiply by 40. You multiply by 40 over 40. Okay, because that is what you want. You multiply by 40 over 40 and make the adjustment like what we did here. Okay, so don't worry about the constant that you have. You just worry about what? Worry what is the constant it should be. And then you multiply by that ratio. Okay, so that will make our life easy. So you don't have to worry about the decimal point, things like that. Okay, so just multiply by that thing. Don't worry about the constant that you have. Just worry about what constant we should have. So you multiply by that ratio. Okay, all right. Any question? Tapi another case, of course, sometimes it's quite easy. Okay, sometimes it's quite easy. For example, suppose u prime is 25x to the power of 7. But we are given, all right, you're given, suppose you have 30, okay, 30x to the power x over 7, but you are given 2x to the power of 7. Okay, so what ratio of constant do you multiply that with?
15.
50? 15.
15.
You don't multiply by 15. You multiply by 15 over 15. Okay, so here you look at 2, and 2 is 30 is 2 times 15. So you can multiply by 15 over 15. All right, so you can multiply by 15 over 15. But if you just follow the pattern that I just mentioned earlier, you don't worry about that too. Okay, what do you multiply by? Multiply by 30 over 30, yeah? Okay, after that, you can simplify. So you multiply by 30 over 30, you got 30 on the top, and then you got 2 over 30, which is the constant you can take out. All right, so you can either look at the pattern, whether is it a factor of the number or is it not, but we can do a blanket multiplication. You don't worry about that constant, you just worry about the coefficient that we should get and multiply by the ratio. Of course, you can simplify it. Okay, all right, good. So that's how we multiply by ratio of constant. So that is example number 4. It's standard power rule, but you have to do some modification in order for us to be able to do the integration. So I'll give you some questions before I forget. Question 12.1. I give you some questions already, but now I'm giving you applications, all right? Application, do 42, 44, 48, and 49. And 12.2, I will let you to do from 3 to 16. Okay, here you don't have to do all, do some. I know you will do until you feel comfortable. And then the applications, I will let you to do 45, 46, and 50. And also 12.4, which is on the application, I will let you to do 1, 2, 18, 19. Okay, so we're done with the concept. Now what we do, we are going to look at application. Okay, so we're going to look at application that will involve, let's see, 12.1. Okay, so go back to 12.1, and then we will look at 12.2 and then 12.4 application. Now the applications is based on the concept of antiderivative for this chapter number 12. So as you know, what is the antiderivative? You have the function, you know the derivative, you want to find that function, all right? For applications, I'll give you an example. Let's say revenue, all right? Revenue R, okay, equal to the f of x. Now, what is the derivative of R? The derivative of R is dx or R prime, which we call marginal revenue. All right. So in this perspective, we know the marginal revenue. Okay, you know the marginal revenue. So what you want to do? I want to find revenue. So we apply the integration. So the integration, if you recall, you have f prime of x dx. I integrate that, I got the integral. Okay. So similarly here, if you are given marginal revenue, r prime, integrate that with respect to x, what do I get? I get revenue plus constant. Okay, so that is example for revenue. Now, similarly for cost, what is the derivative of the cost function? What do you call it? Marginal cost. All right. So if you are given marginal cost, integrate marginal cost, what do I get? I get cost. Okay. And similarly, the profit, marginal profit, the derivative of profit. Integrate marginal profit, I get what? I get profit. So for any application, if you are given the derivative, you want to find the function, we do integral. All right. So let's look at the example revenue. So example revenue, you go to 12.1, example number 7. So look at example number 7. I would like you to read that example because it's quite a long question. You know? So read first, okay, and then we'll go to okay, baca dulu. And then we need to find. Okay, ready? All right. So if you look at this example, what we are given is marginal revenue. So the question say, find revenue. So number 1, find revenue. And number 2, what is number 2? Number 2 say, find revenue where X is equal to 1,000. 1,000 units. So for this example, of course, you have to identify lah X to apa benda. All right, what is X? X is the motherboard, okay, the quantity of motherboard in units. And revenue is, of course, in dollars. So you have to say, apalah unit benda ni, okay? All right, so once you do that, you want to find revenue. So what do we do? To find revenue, you have to integrate the marginal revenue because you are given marginal revenue. So R prime, and that is equal to what? That is equal to the marginal revenue that is given, 300 minus 0.2 F D. Now, I would like to say this. If you have a function more than 2 terms, all right, more than 2 terms or more than 1 term, you have to put the bracket close or open, close. You cannot simply 300 minus 0.2 x dx. This one doesn't mean anything. Okay, what are you doing here? So the function is 300 minus 0.2x. So therefore, you want to integrate the whole function, you put a bracket for the whole function. If you miss the bracket, then doesn't mean anything. Okay, so make sure you understand that, because most of the function that we deal with consists of more than 1 term. If it is 1 term, senanglah kita. Okay, let's say you want to just integrate 300 dx. Betul lah tu, tak payah bracket. But if you have more than 2 terms or 2 terms or more, then you have to put the bracket. Okay, so put the bracket, and after that, of course, you can break out. Okay, you can break out. That's another stage. But at the beginning, okay, you have to make it a bracket so that we are indicating we are going to integrate the whole function, and the notation should be correct. So that's how you do the notation. Okay, so you integrate the function. What do I get? I get 300x minus 0.2 x squared over 2. You simplify that thing, I got 0.1. And of course, plus the constant k. All right? Okay, so that is number one, part one. Now, I want to find revenue at x equal to 1,000. So in order to do that, you have to determine k too. Okay, I have to determine k. What is it in order for you to do part two? Okay, now how can we determine k? We have to determine k. We must know 1 point. Okay, 1 point on the function, so that you can get k. All right. So normally, normally for our application, what you want to do here is, of course, the easiest one is that you want to find revenue at x equal to 0. Okay, x equal to 0, what is our revenue? Because that is the point where everybody knows. Okay, if you are selling something, your revenue, how much revenue do you get if you sell nothing? You sell 0 output. So what is the revenue that you earn? Huh? You don't sell any output. Okay, you sell 0. So what is your revenue?
0.
0, okay? Because that is the simplest point. R is 0. So this one everybody knows. So if you want to find K for revenue, all right, you use that point. When X equal to 0, R equal to 0. So therefore, you substitute to find K, all right, you substitute, I got 0 equal to 300, 0 minus 0.10 squared plus K. So therefore, what is K? K is 0. So your revenue, if you look at the book, your revenue now, after you do the substitution with that point, okay, what you get will be just 300x minus 0.1 x squared. So there will be no k because k is equal to 0. So revenue is equal to that function. Now only we can find revenue at 1,000. So when x is equal to 1,000, x equal to 1,000, then we substitute. Okay, revenue is equal to what? Equal to 300 times 1,000 minus 0.1, 1,000 squared equal to whatever, by what? By substitution. Of course, you can see here, okay, at x equal to 1,000, substitute into r, you get the thing. So we just say my method. Substitution, we learned this from the beginning, okay? Chapter number 1, 2, 3, up to now, we still do substitution. So that is one of the, one of the most common word that we use in the course, substitute. So that is the way. And then you what is the revenue by selling 1,000 units of that. Okay, all right. So I give you already some questions. I will let you to do question number, tadi saya assign 49 kan? Okay, now I want you to try do 49. Okay, do it now. 9, I want you to do now. Try, okay? So you are given the derivative of average cost. You want to find average cost. So what do you do? Okay, go ahead, do 49. So do the first part first. Just do part A. Okay, do part A, and then part B we will do afterwards. So I just want you to do part A. Okay. All right, so do it now. Okay, got it? So you are given what? You are given the derivative of the average cost. Part A, I want to find the average cost of the product. So average cost, C bar, we use the concept C bar. That is equal to what? The integral of C bar prime dx. So that is the derivative. What you're given there is the derivative of the average. So that is equal to put in the numbers 1/4. Now you bring up the x squared. So that will be 100 x to the power of -2. Everything. Okay. So now you can do the integration. So what do we get? We get 1/4 x. Now, the second term, you'll be careful because you have a negative sign. And then I have a negative, I have a negative power. All right. So what is the derivative? You increase the power by 1, so that becomes -1 divided by -1. Put bracket plus k. So here you got negative and negative, so that becomes what? Positive. So they'll be equal to 1/4 plus 100. Now you bring x back down, so that 100/x plus k. All right. We bring down y because it makes sense. Huh? Because you want to do the substitution. So for part B, okay, part B, you want to find the average cost at a certain x. So what do you need? I need that k. Okay, I need the k. So how do you get the value of k? So normally, okay, for cost function, again here, when x equal to 0, what is cost? So again, we do that. That's like revenue. Revenue is not zero. When x 0, R 0. Okay, but for the cost, it is not. So when x equal to 0, normally what cost do you incur? What type of cost do you incur? If you don't produce anything, what cost do we incur? Just give me the name of that cost. What is the cost?
Fixed cost.
Fixed cost. Okay. So normally you are given the fixed cost. That is for cost. But now you are given average cost. Okay, you are given average cost, not cost. But I'm telling you, if you have cost, then normally x equal to 0. The cost is the average, the fixed cost. So they give you the amount, say 1,000. So that is 0, not like revenue. So that is cost. But in this question, you have average cost. But again, you are given 1 point. All right, you are given 1 point. So you use that point to find the value of k. So what are we given? You are given at x equal to 20. What is the average cost? Average cost is 40. So we can find k. All right. So you substitute into C bar to find, because you are given, we are not given x equal to 0. What is average cost? You're given 1 point. So make use of that point, whatever it is. All right. So here you're given x equal to 20. The value of the dependent variable is 40. So we put into that thing, I got 1/4 plus 100 over x. Berapa dapat? Cuba buat tengok. What do you get? Ya, betul ke? You check my integration, is that right? Ni. Don't forget, I missed that X. So X what is it? I missed that. How come I missed that? So you got 1/4x. So you substitute, what do I get? I get 40, okay, equal to 1/420 plus 100/20. Ada apa? Ada? 50 plus 50 plus 5, 20, 55 lah. Betul tak? 55. No, 5. Here is 5. 5 plus 5, 10.
Then yeah.
Oh, no. I'm wrong. Ni salah ni. Dia ada K. Plus K. Kita nak cari K. Alright. So, A is equal to 40 minus, this is 5, that is 5. Minus 10. Alright, so 30. So K is equal to 30. Am I correct? So you check. You get 30 or you don't get 30. If you don't get 30, let me know. So maybe I'm wrong. So your average cost will be equal to 1/4x plus 100x, 100/x, I'm sorry, plus 30. So now you got that 30. Okay, so the value of K is 30. Check my answer. K 30, betul ya? Okay. So after that, then only you can answer part B. Find the average cost of producing 100. So again, you substitute, then you get the average cost of producing 100 units. Okay, all right. So that is 12.2, 12.1, the application. Now 12.2, I give you a few examples, a few questions. The concept is the same. It's just that the type of function are different, you know. So you have to apply the general cover rule. More difficult function. Now 12.3, for now we don't do it yet. If I have time, maybe afterwards, you know, we can come back to do 12.3. So we move to 12.4. 12.4. 12.4 application, sama aja. You have the revenue, and then I want to look at cost, right? And then I want to look at consumption. So let's do cost. Okay, example number 2. So example number 2, you have what? Read that example first. Read the example for 2 minutes. The average cost. Okay. Now is the cost proper. So 12.4. Okay, all right. So you have to know what is X and then what is the cost. And then what you want to find here is you want to find the total cost. All right. So you have to find number 1, the cost function. Number 2, you want to find what is cost at X equal to a certain quantity, here 300. Okay, all right. So that is the problem. Now you are given the marginal cost. So you know that you integrate the marginal cost, you get cost function, or sometimes you can call it C prime. Okay, so it's the thing. So you integrate the marginal cost, I get the cost function. So that will be equal to, you put in the value, the exact function. Okay, so I got 3x, 2x, 2x plus 25 to the power of half. So that is the marginal cost. Okay, so that is the marginal cost. So what do we do? Here you have to apply the general power rule. So you let u be equal to 2x plus 25. Now, what is u prime? U prime is 2, okay? But what do you have? But we are given, or what we have is what? 3, okay? And 3 is not u prime. U prime is equal to 2. So how do you get 2? Multiplied by what? Ratio of what number? You have 3, okay? You want 2. So what do we do? Multiply by apa? You multiply by?
4/2.
You don't multiply by 4/2. That is half correct. You multiply by 4/2. You have to be careful. 4/2 is equal to 2. That is wrong. You have to multiply by a ratio of a number that is equal to 1. So you must have the denominator same as numerator. If you have to multiply by 4, it should be by what? 4/4 equal to 1. That is correct. Okay. But you cannot multiply by 4/2. That is only half correct. So you multiply by berapa? Yang cakap 4/2 tu. So now what should the number be? You multiply by what?
2/2.
You multiply by 2/2. Okay. So the right one is you multiply by 2/2. Why? Because I need 2. Okay. Don't worry about that 3. Okay. All right. So what you have now is this. I write down the integral. So I have 3. Okay. You write down the 3. And then you got 2x plus 25 to the power of half. You multiply by 2/2. So you bring the numerator, the denominator outside. So that is equal to 3/2. Now you have the form u prime and u. I'm sorry, not u prime. It's u prime. That is equal to 2 dx. Okay, so I have u prime. So that is equal to what? It's equal to 3/2. You have u, which is 2x plus 25, raised power by 1. So that will be equal to what? That will be equal to u to the power of, you add 1, so 3/2. So I write in terms of u. Or if now you know that u is equal to 2x plus 25, you can right away put it in. So let's do that. I just write it in, 2x plus 25, increase the power by 1, so I got 3/2, divided by 3/2. Betul tak? So you have 3/2 divided 3/2 multiplied by 2x plus 25 to the power of 3/2 divided by 3/2 plus constant k. So you have 3/2 divided by 3/2. Senang kita cancel out. Okay. So you got that function. So you have 2x plus 25 to the power of 3/2 plus k. So now you want to find k. So what do we do? You are given the fixed cost. So to get the k, okay, to get the k, you are given fixed cost. So cost is equal to what? Is equal to 11125. So what is the fixed cost? Fixed cost ni, the cost that you incur at x equal to 0. So at x equal to 0, the cost is equal to 11125. Okay. So what you do, you substitute into C. So what I have is 1, 1, 1 to 5 equal to, all right, equal to the 2 times 0 plus 25 to the power of 3 over, okay, plus A. Then what do I get? Need 0. So 25 to the power of 3 over 2. So if you look at the book, you get 25 to the power of 3 over 2. That is equal to 125. So 125, that is 125. You bring it there. So you work this out. I get K equal to how much? K is equal to 11,000. So you cannot assume, okay? You cannot assume the K is the fixed cost. Okay, that is not correct. Okay, that's not how do we do it? How we do it? You have to use that point. What is fixed cost? Fixed cost is the cost at x equal to 0. Okay, when x equal to 0, the cost is 11125. And then we substitute. Then you get that K. Okay, don't just say fixed cost is 11125. Therefore, K is equal to 11125. No, that is not right. Okay, that is not the way to do it. You have to understand fixed cost. All right, x is equal to 0, C equal to 11,125. Then substitute the cost, then you get K. Okay, all right. Any question? So that is cost. And then the other example that I would like to look at is the final one, the national consumption. So national consumption is example number 5. Now, national consumption is macroeconomics. We are not talking about consumption of a person or household. We're talking about consumption for the whole country, okay, for the whole economy. So you have what? You are given the derivative of the national consumption, dy, dc, dy, and then you want to find consumption. Okay, all right. So here, if you look at that example 5, consumption is C, notation, okay, I just write notation. Consumption C, that is in dollars. Dollars, $1 million, $1 trillion. Okay, $1 trillion. Okay, is equal to trillion. Trillion. Trillion is 0. Okay, and then the income, disposable income. Okay, disposable income. Disposable income, the income after tax. So disposable income is the income you already deduct the tax or disposable income. That is how much you spend, and that is denoted by Y. So it's not X. Okay, so don't be confused why they use Y. Okay, Y is not the dependent variable. Y now is the independent variable because they use Y to denote disposable income. Okay, so that's why for application, we have to look at what variables do they use, and we have to know what are the variables. So don't worry why X, K, H, C, P, don't worry about those. We just worry about which one is the dependent, which one is the independent. So here you have C, and C is a function of Y. Y is the disposable income. Okay, so you have consumption, C, function of income, Y. Okay, so that is in the functional form. And you are given the MPC, marginal propensity to consume. That is the derivative of, we can also say C prime, because the C prime now is dc dy. Okay, so you are given dc dy, the MPC. So consumption is equal to what? Is equal to the derivative of, I'm sorry, integral of dc dy dy. Or you can use MPC or C prime dy. All right. So put in the value, put in the function. You are given what? 0. Don't forget the integral sign. 0.3 minus 0.4. 0.4 divided by square root of y. Square root of y is y to the power of half. You bring that up. So y to the power of negative half. Everything dy. All right. So that is our function. So again, you integrate that, you will get the consumption function, and then you find k. So how do you find k? You are given when income is equal to 0. Ini senang cerita. Okay, so you got the consumption, right? Plus k. So you are given when y equal to 0, c equal to 6 trillion. So substitute situ dapat. Okay, so we just finish up that example, and then you can read also on the MP. Okay, so MPS is not difficult. Okay, all right. I give you already some questions on this part. 12.4. Yeah, I did. So those questions, and that's it. We're done with 12.4. 12.5 we don't do. So that's it. We are finished with chapter number 12. So 12.5 we don't do. Okay. 12.3 we also don't do. If I have time, I can come back afterwards. But for now, we skip. So we are done with chapter number 12. Okay, oh, dah azan ke belum? Kalau dah azan, apa ni? Now it's asal berapa? Selalu 4:20, 4:28. Okay. Now you go to chapter number 13. Okay, chapter 13 is on definite integral. It's extension of chapter 12. Okay, chapter number 13. We call it definite integral. Okay. 13.1. Okay, 13.1 is the concept, theory. We are not concerned with that. So what you want to do is just to understand the idea. Okay, so we start with 13.2 to understand the idea of definite integral. What is it? So this is the definite integral. So we start with 13.2. Okay, 13.2. Definite integral. Now, chapter number 12, I just say integral, all right? So chapter 12 is indefinite. Indefinite integral. Or just call it integral. But another name for it is indefinite. Now, as opposed to definite integral is we are taking the integral, all right? You take the integral of a function of y equal to f of x over n interval or between 2 points. So that is why you call it definite. Okay, because definite means you see that thing, you want to get the integral between 2 points. Say, all right, x0, y0, and x1, y1, such that x0 less than x1. Okay, and we consider only x, y, both are positive. We don't worry about negative values. Okay, we worry about the positive values of x and y. So first quadrant, at the graph, we only worry about this part. Okay? Don't worry about that thing, don't worry. We only worry about that part. All right. So that is a definite integral. You are taking the integral of a function over an interval or between 2 points. So suppose the 2 points are x0, y0, x1, y1. So now, what is the integral of that function? So the integral of that function, you call it f, which is what we already know, or you can call it a, ya. Afterwards, I will explain to you. That is equal to what? That is the integral of f of x dx. From where to where? From x0 to x1. So that is the notation for definite integral. You are taking the integral from one point to another point. Okay, but make sure that point x0 is less than x1. Okay, and x and y are both positive. So what is it equal to? Okay, in order to do this, all the rules will hold. We don't need new rules. Okay, the rules that we learned earlier are the same rules. We are doing the integration over one interval. So that will be equal to f of x, the integral of f of x, f plus c. Okay, plus c. And then we are going to do it from one point to another point. So you just do a straight line, x0, x1. All right. Now x0, x1 is definite point. It's a real value. So what do? We can find the value. So you have the value at x1 plus c. So you evaluate the function at x1. And then you subtract the value of the integral at x0 plus c. So c and c cancel out. What I have is the integral of the function at x1 minus the value of the integral at x0. And x is a number, okay? It's a value. So that value will be, we call it f or we call it a. Okay, all right. So example, I give you an example. Suppose you have the function y equal to 2x plus 11. Okay, y equal to x plus 11. And then the interval, all right, the interval, or from one point to another, we call this x equal to 1, y0 equal to, when x equal to 1, kita kena follow lah equation ni. Okay, when x is equal to 1, y equal to berapa? 11 plus 2, 13. Okay, and then say the other point, say 5. Okay, when x equal to 5, 5 times 10, 10, 10 plus 11, 21. Sorry about that point. Okay, all right. Now, when you do interval, you just look at the value of x. So the interval, you write down interval, you put the bracket 1, 5. So that is the interval between the first value of x to the second value of x. So we don't worry about the y. Okay, so interval, that's the value of x. First value, the second value. The beginning value, the end value. All right, and then you put the close. Okay, any question? Okay, good. So that is the integral. So we go back to that example. Okay, so the example that I have is, say, f equal to a. I write both, but you don't have to write both. You can just write only one. The integral from 1 to 5 of 2x plus 11 dx. Macam tu lah. Alright, so you are given the function 2x plus 11, and you want to take the integral from 1 to 5, just the value of x. Okay, from 1 to 5. So you put in the notation 1, 5. Okay, you write 1 at the bottom, 5 at the top. That is equal to what? That is equal to, you do the integral 2x squared over 2 plus 11x. All right. Now put the straight line 1, 5. You don't need the c. Why? Because c you cancel out. Okay, tak payah buat c lah. Okay, so you got that cancel out. So what is it equal to? Now you evaluate the value of the integral at both points. So that will be equal to 5 squared plus 11 times 5. So that is the first value. Okay, that is fx1, the end value. Okay, minus f1. So that will be equal to what? That will be equal to 1 squared plus 11 times 1. So I want to be consistent. Okay. So ini fx1. That is fx0. You take the difference. So what you see here, specific value. Okay. So what is the value for the first one? 25. 25 plus 55. 25 plus 55, 80 lah. 80 minus 12. So that will be equal to 68. Betul tak? 68. So that is the integral. The value of the integral, or that is the definite integral of that function, 2x plus 11 from 1 to 5. Okay, any question? No, if you have a question or anything that you don't understand, you ask me now. Okay, don't let this thing be dragging to you because we don't have that much time. You have to understand it now. All right, there is no time to understand tomorrow or the next day because by Wednesday we are going to cover new things. Okay, you get the concept? Anything that you don't understand, you just tell me. I will go over one more time. Okay, all right. So, what is that definite integral? What is the meaning of it? Okay, this is the meaning. We show the graph. Okay, so I show you the graph of the function. 0, y. Now, in terms of the graph, it will be like this. Let's say y equal to f of x. It's like that. And then you have the first value, x0. Second value, x1. Of course, it will be corresponding y0, y1. But, to find the integral, you don't need the value of the y. Or if you look at the book use a. Okay? X1, the book use b. So, somewhere. So our interval is x0, x1. Or Okay, or same thing, A, B. All right, I use X because it's now not really, because X is equal to X0, X equal to X1. Now, the definite integral is the area under the curve y equal to f of x from x0 to x1. So the definite integral f is equal to the a. So that a, which I used earlier, is the area. Okay, it's the area under the curve. So definite integral is the area under the curve between the 2 points that is given. All right. So for our example, we look at our example. Now, our example, what is the function? How does the function look like? Example kita tadi tu. What is the function? 2x plus 11 lah. 2x plus 11, 3x plus 11. 2x plus 11. Now, how does the curve look like? 2x plus 11. Anybody remember? 2x plus 11. What is the y-intercept and how does the line look like? We just need to sketch, all right? We don't need to find, we don't need to draw, okay? But give me the intercept. What is the intercept on the y?
11.
11. So it cuts at 11. And then the line, how does it look like? Straight line. Okay, straight line going up like that. So that is y equal to 2x plus 11. Just sketch the line. Now, you want to find the definite integral from x equal to 1 up to x equal to 5. So what is the definite integral? It's the area under the line. Okay, so the area under the line is the definite integral of the curve 2x plus 11 from 1 to 5. And that is the area. So what is the number that we get? You get 68. 68 the area. Or if you remember, what is the unit for area? You remember how do you get the area from a simple area? What is the unit for area? Area, how do you get area? Area is what? Area is length times width. Is that right? So the unit of area, unit there, unit squared. Okay, so unit squared, but you don't have to say that lah. In our case, you just don't say, you just say dollars there, right? You have to say unit squared. Just say the definite integral is equal to that, or the area is just equal to 68. So in that case, area is equal to 68. Now, what is 68? Is the area under the curve 2x plus 11 from 1 to 5. Okay, all right. So what we have done is two things. Number one, we define the definite integral, the concept, and then we relate to what? We relate to the area under the curve. So they are equivalent, okay? They are equivalent. So that is definite integral. So I take a break because of the azan. I will come back afterwards. You got it? I'll just give you, because time is already up. I'll just give you one question, okay? I want you to do it immediately after the class. Example 2. So I give you y equal to f of x equal to x squared. Simple function. You find the definite integral, okay, f equal to a, that means the area under the curve of f of x, okay, of function f of x between x equal to 2, x equal to say 7, or in terms of the interval 2, 7. Okay, so you do the definite integral. Okay, do the definite integral. And then I want you to sketch. Okay, sketch the graph. Show me the area. Okay, show the A. Sketch macam ni lah. You don't have to draw. All right, you sketch. Well, you just give me how the curve look like this. Okay, straight line, intercept 11. So similarly for this one, we have been doing this for the derivative. By now, you should know how the line x squared look like. Okay, so you sketch the curve, how it look like. I don't draw a straight line, okay, because that is not a straight line. Then you show the A, and then you find the definite integral, so that you can relate. The definite integral between the 2 points is the area under the curve from the same point. From the same point to the other point. Okay. All right. So I will leave you here, and then I will continue on Wednesday from there. All right. Anything? Any question? Anything? No? Okay, good. So I'll see you again. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam. Thank you, sir.
Thank you.
Waalaikumsalam.
Waalaikumsalam, sir. Thank you, sir. Have a nice day, sir.
Yeah, you too.
Thank you, sir.
Okay, thank you.